Currently, he is working as a postdoctoral associate in Department of Biochemistry of University of Rochester, USA, and he is going to talk about the role of seasonality control of respiratory virus. So I would like to welcome Dr. Javid Bhatt to please join us. Dr. Javid, welcome.
Oh, sorry. First of all, I'd like to extend my thanks to Dr. Navshad Khan and other co-hosts and university for giving me this opportunity to talk on current crisis. Though I'm not a virologist, if I'll be going a little bit in information here and there, forgive me for that. But I'll try in best in my MBA to talk about seasonality of these respiratory viruses. Yes. Okay, let me begin. First of all, I hope that each and everyone is doing well at their respective places, because as we know that what kind of a mental burden especially this coronavirus has brought to us. And my peers, my other colleagues were talking about the different aspects of this coronavirus, and I thought that I'll choose a little bit different topic, that does seasonality affect these respiratory viruses. And in that regard, you know just this is not for a securing, just when we were going through the other talks, I just went to the worldometer and tried to just show how severe this coronavirus is. If we could see, like, there are more than 300,000 deaths, though there's a lot of recoveries as well. And you could see that how many active cases are still there and how many cases have been closed, which either have died or recovered. But let's go a little bit into the background of these viruses. Does they really are seasonal dependent, or they occur throughout the year? What are actual causes? When we try to go into the earlier literature, long back, you could see that around 400 BC, he has mentioned of those respiratory infection viruses, and since there it has been shown to be the cause of etiological agents of these such epidemics. Let me take the estimates of other common viruses. Like if we take a common cold, it alone costs US almost $40 billion a year, and influenza virus costs $87 billion a year. So that means they are not new. They have been causing these havocs throughout the decades. Only the change and form comes in a new way. Currently, if we'll be looking into the current this COVID-19, or SARS, which have been actually which was discovered early in 2001 in China, where we saw that something of pneumonia kind of a thing occurred in 2001, which was named as severe acute respiratory syndrome that time. And currently, when in Wuhan recently this outbreak occurred, it was again named as a SARS-CoV-2, because it is a more or less modification of the same virus. Now, here's the one important question, which I have been going through the pros and cons of it, like from the both sides. Few virologists of a concept that it is not possible for virus to evolve naturally in such a short span of a time to be such a dangerous thing in 18 years. They believe that it may take it 800 years to evolve, naturally and have a such severity. But some virologists believe that as there's L and S form, that L is less virulent, S is more virulent. It might have changed it into the virulent form, but I won't be going into that debate whether it is a whether man has triggered something into it or it is naturally occurring, because we don't have enough data to support either of the claim as of now, because studies are going on right now. But if we look again, the origin of these viruses, as I have shown, like, they are still unknown. Not only they are unknown, but their occurrence in nature are still mysterious. But they does follow some general patterns of pathogenesis, and that are noticeable from their epidemics. Both SARS, this CoV-2, and SARS COVID-19, they follow the same pattern of infection. They use same receptor, like you could see here, this antagonism converting enzyme to invade human bodies. Apart from this human coronavirus, like, these two kind of active viruses, in recent past, like in 2012, there was, as my other colleague Chaitanya was talking about, this MERS-CoV, which occurred in 2012 and which was named as Middle East Respiratory Syndrome. It does use different kind of a respiratory, this receptor to attach to human beings. And now, what is interesting here is that both of these epidemics has occurred in a cold weather, in a winter season. Is this like just mere coincidence, or there is particular connectivity between particular seasons and these kind of respiratory viruses, which we'll be discussing in coming slides. But we have to follow some pattern, like, we have to understand the chronology, like all these recent epidemics and pandemics has occurred in the holiday season, usually related to the dietary consumption of wildlife, which is usually a fashion in some countries. So if we would look into the phylogenetic analysis of these viruses, there are a lot of almost 52 isolators of the SARS-CoV which have been isolated. But these four or these 10 isolators, especially these two, three isolators have been considered to be the main virulent one, which they believe that they are close to the COVID-19, and it has evolved from, you know, such like strains which have been previously isolated. Now, there's a one interesting thing, like how does this spread? People believe that it has occurred from there might be intermediates, they are insects, or there might be intermediates, penguin is there, snake is there, and mice is there. So all of these kind of things you could find in a market, like, they are available in wild type markets, especially in the China. What happens is that these bats are usually attracted towards lights, these green, these red and green lights. Once they come towards it, they are highly infectious, those insects. Some groups believe that they infected them, some believe that from them it has transferred to the different intermediates and then to humans, or it could be a direct transmission. If we sorry, if we look at the outbreak, this picture is right from a Wuhan, the day Wuhan was closed, when we were not knowing what COVID-19 is. So, which was later on, of course, named as, like, CO, which stood for corona, and VI virus, and D for a disease, which were named by World Health Organization later on. But you could see these two areas where there are a lot of lights. You could see here these two regions, like Wangzhou River Bridge and Wuhan River Bridge. Many groups believe, like, they were the epicenters where from it actually you know evolved and then entered into the other areas. Now, our main thing is, like, as I mentioned before, that there have been coincidence that these kind of epidemics has occurred in winter seasons. So how does this winter season affect? We need to understand some relative terms here, like respiratory tract. I guess most of the people on the panel might be knowing, especially mouth, nose, throat, including respiratory bronchioles and alveoli. Then there's a one term, absolute humidity. Absolute humidity, we need to understand this, that absolute humidity does not change when air is heated or cooled. And another term is their viability of these respiratory viruses. What are their interactions with hosts in vitro? And then there's a thermal comfort zone. As I have already made it in a red, that roughly 20 to 24 degree have been uh, you know made as a comfort zone for those respiratory viruses where they work to maximum. And then there's a relative humidity. This is a very important another important term which does change with the relative environment. Previously what used to happen was like, there was a lot of outdoor interaction of people, like people used to do farming or day-to-day activities outside. But with industrialization, what has happened is that those are big industries have taken over the farming. All each and every part of life has been taken to indoor, and now when we remain in the maximum part of our life indoors, so the bacterial flora which we were supposed to interact with has over the period of time it has got lessened. And what happens is that once winter approaches, these particular the terms like absolute humidity, relative humidity, they change from inside to outside. And how does they help those viruses? That's an important question here. As Chaitanya was before some time explaining the spikes on the coronavirus, he has depicted beautifully that photograph on outside. But they are actually very much dependent on temperatures, relative humidity, absolute humidity, thermal comfort zone, that how they will be attaching towards these human beings, whether their survival will be the maximum or not, and whatnot. So let's look on this effect of seasonal climate changes. When seasonal climate change occurs, you could see like there's a temperature, there's absolute humidity, there's a like just give me a sec because options. Okay. You could see like there are temperature, absolute humidity. Then there's one more important factor which we need to take into consideration is that there's a sunlight. That means we have a less vitamin D during the winters, and that does affect the immune system in turn. And there's a then indoor temperature, indoor environment will be that temperature and humidity will be related to the outside. Then there will be the air change, and in turn you could see that air way like that host defense will be acting according to the environmental conditions only. When there will be the colder temperature, there will be the lot of whether innate immune system will be there, whether antiviral immune defense will be there. It will depend how it will activate in accordance to the weather. So once this relative humidity or absolute humidity or variation in the temperature occurs, what happens is that there is a visibility of viability of viruses. Then there is a droplet, which we knew that like in winters it does happen. And in case of a coronavirus, there has been confirmed studies via lasers and all those things that in a closed space it could survive, these droplets could survive to 4 to 5 hours. Why so? Because in winters we know that the temperature due to the low temperature, this air could not hold much of a water, so it is not letting it down to settle on bottom of those surfaces. So it take a longer time as compared to when it is in other temperate regions like or tropical regions, when it heat will be much more, where this absolute humidity or relative humidity becomes absolute due to the heat and moisture, where it settles much faster. So what happens now here is that once you see that this infected host, from this infected host and susceptible host, we have a lot of indoor activities during winters. We share office, we share almost 90% of life, our life happens indoors, a little bit 10% happens outside. So there's every chance that those airborne aerosols will be responsible for the mode of transmission. There will be the indirect these transmission of viruses as well. There will be droplet spray as well. And human behavior, of course, if we could take home, school, hospitals, holidays and school opening, all these things does matter. And among them, potential drivers of seasonality, fluctuation in temperature and this absolute humidity has been proposed a critical factor for these respiratory infections, and especially in context of those winter epidemics. Moving forward, if we could have a quick look on the seasonality of these respiratory viruses, how does they occur? you could have a quick look on this chat. Like from November to April, you could see their influenza virus will be active there. Then human coronaviruses have been found active there, and then there's a RSV viruses. There are all air viruses as well, like adenovirus, human papillomavirus is there, and they have been broadly divided into three categories: summer viruses, then winter viruses, and all air viruses. All air viruses again have been seen that they do pick up. They infect usually their hosts in spring, but towards fall they are more severe, or their severity increases, and it all has been correlated with their efficiency to attach to the host due to the environmental factors, and their replication again plays a main part, that why don't they overlap each other's cycle. It has been found that when influenza virus came, this RSV virus did delay its replication pattern. Maybe there might be other factors responsible, but especially in temperate regions, this kind of a pattern has been followed since decades. Then if we could see if we could continuing, if we could see the climate season changes here, there is something important to note, is that when indoor relative humidity is 60 to 100%, respiratory viruses stability has been found high. Proportion of droplet nuclei, of course, due to the high humidity would be low, and viability of respiratory viruses again is high, which does form a direct or indirect contact. Again, when temperatures are low, it has been again found to be high and predominantly airborne. But something has been found, like in between relative humidity of 40 to 60%, there has been studies on guinea pigs, mice, and other things, where they have shown, like it somehow becomes intermediate kind of a thing. It doesn't get deactivated, but it becomes less virulent. And most recently, analytical approach revealed that how low temperature conditions may promote ordering of the lipids on viral membrane, as well as contribute to the stability towards of influenza viral particles towards host. Then there's a transmission of these viruses, because what we find is that usually during high temperatures there will the virus specific adaptive immune system. Then there will this interferons will be playing important part. Mucillary clearance will be there, which is the first line of a defense for any airborne disease or respiratory diseases. And then there will be the if there's a damage to the those epithelial tissues, it will get repaired within 12 to 18 hours. But all those things you are seeing on the left side, that this does happen with like during a normal temperature. But what winters does is that when it takes water away, when it makes there's an interesting fact, is that it has been seen that influenza virus, what it does is uh, when our body is having a 37-degree temperature, and when our nose due to outside gets cold, it is having a somewhat around 33-degree temperature. And it has been found in vitro cultures that it does grow on a 33-degree. It grows in a you know very efficiently. Its log phase is very virulent, and so has been found that it does infect at that time because of the temperature differences between body and outside. And all those things have been found that it at that time, what it does is it affects this extra thoracic and tracheal airway damage, mucosal damage is there, and ultimately transmission of respiratory viruses becomes prevalent in winter seasons. Here is one important thing, how does it affect the airways? Usually what will happen is that once any respiratory virus comes, suppose here respiratory viruses comes, it will be trapped, like this virus will be trapped here in these ciliary particles, because of there's a first layer of a defense here. So what happens is that usually this mucillary layer is composed of almost 93 to 95% of the water, and it encapsulates this any respiratory viral particle there. It doesn't allow it to attach to the epithelial cell until and unless this respiratory virus will attach to the epithelial cell. It can't go beyond and infect. So this is the first line of a defense there. And then will come second line of defense will come this epithelial cell layer, which will be consisted of a single layer of a mucus. But what happens during dry air is that when air gets dehydrated, when there's a less water, ultimately these cilia gets what I'll say is that these cilia gets immobilized. When these cilia gets immobilized, they reduce the height and dehydrated, and they compress it, and this virus flow becomes more prevalent, and it can attach to the epithelial cell layers, and ultimately it could break this first layer of a defense of human beings, and it could infect. And most importantly, finally what I like to discuss here is that once this first line of a defense comes into play, there are other defense which in the body overtakes, like there is a innate mechanism where you could see that phagocytosis, reactive oxygen species, monocytes, macrophages, all those increased sensitivity of inflammation will come into the play. But as again I was explaining, like how these dry weathers, how these cold air are less sunlight, vitamin D deficiency, all those things come into the play. They let this mucillary layer to compromise. Once it gets compromised, it gets infected. And moreover, usually, as I was saying, like this epithelial layer, once this epithelial layer gets repaired from 12 to 18 hours, it doesn't give it such a time to repair it. It has been already seen in guinea pigs and other things that it doesn't give it such a time so that it can repair. And ultimately it increases the virulence of these particles, and it does compromise, and pneumonia like conditions does occur. You could see on the right hand that what does dry weather cause. So whether this coronavirus or COVID-19 is really a winter virus, as we could see, like my other colleague Nadeem, he was from New York, as well as I reside in New York, in the one of the city of the New York as well. We knew that this part of the world is affected more. Rather, the cold areas are affected more as compared to the temperate areas. Now only time will tell that once the spring comes up or once the summer comes up, whether this virus will show different patterns, or this will show the indication of the liners as it used to show with as it has shown with the previous viruses, that whether this is again a kind of a seasonal virus which will get over with the you know uh, time frame. Though we have a lot of cases which have been found in the tropical regions as well, but virulence has not been found as such. A great example is Pakistan, India. You could find that the death rate there is not as such as it has been like in the other parts of the world. But only temperature won't be the only reason that which will be overcoming it. And only time will tell us that whether it is again a seasonal virus, or it does have something different with it, because it is a mutated virus. It does change every day. Until and unless we will develop a immunity against it, we have to live with it. So finally, what I like to say is that there are some tips for limiting these respiratory virus transmission in winters. What are they is that we could humidify our indoors to maintain at least 40 to 60% relative humidity of room temperature. Ventilation of indoor air is necessary. So is during this coronavirus, because it is recommended that uh, keep your rooms ventilated, so that if there is some droplets of a coronavirus in a airflow will it will flow it outside. And then of course wearing a face mask to keep nose warm and moist, so that such viruses could not harbor there. And again, the matter of the fact is that in US, if we don't take cold flu shot, we are supposed to wear a face masks. But then I know here it is they usually provide in order to compensate for the vitamin D, they usually supplement it with a milk, and so at other places vitamin D should be supplemented, and it should be replaced with the proper appropriate measures. Then of course sleeping does help a great, that is a great job to our immune system. How our immune system gets boosted due to the sleep, it is a very important part. At least 7 hours, 8 hours is recommended, like 7 hours should be there. Then washing hands to prevent indirect contact transmission. And washing should not be such that your bacterial flora will get away. And yes, we need to get outside and interact slowly with our natural environment, so that we may boost our immune system sooner. We do that, that's a better thing for us. Thank you very much. And this is a group where I'm working, and acknowledgements to all of those. Any questions?
I have a question.
Yeah, please.
Yes, please go ahead.
Your voice is breaking.
Sir, is it coronavirus affect recovered patients?
Wasim, you are not audible. Please speak clearly.
Sir, is it possible that the coronavirus affect recovered patients again?
Coronavirus effect is?
There is a lot of background noises.
Wasim, you are.
Mute your microphones, please. I mean, Wasim is asking some question. Please let him ask some question. Wasim.
Yes, sir. Sir, is it possible that the coronavirus affect recovered patient again?
You mean
What he's asking, that is there any possibility of a person who has infected with coronavirus to recover again? That's what you are asking?
Yes, sir. Yes, sir.
recover or infect again?
Infected patient recovering again. He is asking this question.
No, the matter of the fact is that there has been a patient who have been found that once they got recovered, they got infected as well.
So, sorry, please mute your audio phones, please. Don't make background noises, please.
Wasim, there has been the cases where it has been found that the guys who have recovered from coronavirus, they got reinfected. So the mechanism of action as of now is not totally clear. Though the majority of the cases, the ones who have got recovered is having a high possibility that they won't get reinfected again. If they get reinfected, that they will be having a first line of defense there. But there has been cases where people have found that the guys who got recovered due to this coronavirus after their quarantine period, they got reinfected again.
Okay, thank you, Dr. Javed, for your informative talk. But what I really liked about your talk is that for limiting respiratory virus transmission in winter, it's the sleep, that we need to have sound sleep of more than 7 hours per day, which you are you are expert in doing this. So I really like this idea of sleeping more than 7 hours per day for limiting this transmission of coronavirus in winter.
No. It is not like it's not for coronavirus. Actually, it is for overall to keep your immune system intact.
Okay.
Okay.
Thank you, Dr. Javid.
Excuse me, I have a question.
Sure.
Okay, Mr. Javed Okat, thank you for your presentation. You said that appearance of coronavirus has mysterious nature. Nature. What do you mean? What does it mean?
Like there are there are a lot of known virologists. There was one interview who has been which has been taken out of YouTube now by the US government, where one of the leading virologists says that to her she believes that if coronavirus has to evolve in such a nature that it would take coronavirus at least 800 years to evolve with such genetic mutations. She believes that there might have been a triggering with the current COVID, already, which was coronavirus, which was there in the
Okay.
laboratories in between China and USA. But I'm not expert on that, so we could not take those, one or either side just on a limited resources. Let us give some time. More of the literature will come inside. Not only she, there are a lot of other known virologists, Nobel laureates, who say like they suspect the devious nature of this virus. So let's wait and see how literature goes and what's the final outcome. This might be in a maybe in coming 5-6 months. Nature, once we understand its pathophysiology fully, how it has occurred and how it has evolved, we may be able to answer what's the nature of the virus. But still, the 2002 coronavirus is still kind of a mysterious.
Yes, thank you. So, what do you think? Can we speak about a mystical side of this phenomena?
Sorry, could you come
Is
again?
it reasonable, mystical side of this phenomena? Is it reasonable, this suggestion?
Like, being a student, like what I'll tell you, that I'm not expert in virology, so I can't make an opinion. But the leading virologists who have made opinions, it is then either side, that when you read both of the sides and once you understand it is biology to a full extent, then only you can make an opinion. But I'm not that much literate in this field as of now that I can make opinion of my own. But I don't rule out it. I could
Okay.
not rule it out any possibility.
Okay, and the second question, you said about Hippocrates. Hippocrates, ancient Greek medicine,
Yeah.
Hippocrates, and his book Epidemic. Okay.
Yeah.
So, can we find information, concrete information about this virus in ancient books?
I actually, I have not looked into that thing, whether we could find information regarding this virus, but you could definitely, there's a reference, I have given reference in, here.
Okay.
You could find the link to the book, and where you could, most probably look for these kind of things.
Okay, thank you very much.
Yeah, you're welcome.
Yes, so thank you, Dr. Javed, for your interesting talk. What I feel, based upon the available evidences, it is not fully established, but we believe a number of parameters can come into play, and I think that not all virus shows higher peak of infection in the winter, but for respiratory virus which do peak in winter, important factors seems to be the availability of the actual virus